Hello, I know what you're thinking. What if I could get all the answers to LeetCode problems in actual English? Well, you've come to the right place. Oh, also, the answers are in C++, so let's get going. This is TwoSum, probably the most famous problem you're likely to encounter. It says, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input will have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay. So now we have an example. So the input that you get is nums equals an array which of elements 2, 7, 11, 15, and the target is 9. So you see that 2 plus 7 equals 9. So you return the indices of 2 and 7, which are 0 and 1. Then in example 2, you have 3, 2, 4, and the target's 6. You see that 2 plus 4 equals 6, so you return indices 1 and 2. Then 3 and 3, and the target is 6. You see that 3 plus 3 equals 6, and therefore there you return 0 and 1. Okay, so how do we do this? Well, the first thing we'd like to do is do some sort of kind of sanity check. And for that, we write something like if nums.size smaller than 2, then return an empty vector. And that just means that if there's no two numbers to send back, then we return an empty vector. Well, the next thing we do is we come up with a return vector, which we'll call myReturn. You could do this in C++. You could initialize the vector to nothing. That's kind of proper idiom. And we're going to do a bunch of stuff, and then we're going to return this myReturn, which is going to have something in it. Now, we could do some sort of brute force check, meaning that for each number, we go through all the other numbers and we check if there's a match. But that would take an exponential amount of time. Instead, meaning n squared. Instead, we could do something a little bit smarter. We could say, hey, if we already saw this number 2, and when we get at number 7, we say 9 minus 7 equal, we just check, well, 9 minus something, so if we look at this, if we look at what we're actually looking for each number, say we're at number 2, we're asking if 9, have we already seen the number 9 minus 2 equals 7? And at that point it's no. So we should store the number 2 somewhere. Then when we get to 7, we ask the same question. Have we seen the number 9 minus 7? And that's 2. And have we seen it? Yes, it's here. The best way to do that, to store that in some place in which we're going to store the integer representing the number that we saw and the index at which we saw it. So let's see. They tell you, by the way, that there's only one solution. So there's only one index in which you could have seen it. For this, we use an unordered map, which is a hash table. We'll call this already seen. And we know that that this is actually the number we've seen and its index. That's what we're looking at. So then we go through then we go through nums. For int I equals 0, just a regular loop, I. Okay, so that's our little array. Sorry, that's our little loop through nums, and we're going to say, okay, if we've already seen, if we find target minus nums I. If we've already found it, meaning we didn't get to the end of already seen, then we could push back the values we want. So my return dot push back already seen. And what do we want exactly? We want the index over here. So we want target minus nums I. And we also want to push back the current index, which is I. And then we're going to return my return. We could already do that here. Now, if we didn't find it, well, then we just need to add it to already seen. And how do we do that? We just add the particular number equals its index. And I think that should do it. So if we run the code, looks good. And if we submit, also looks good. Okay, so runs fast, everything's fine. Thanks for watching.